Let's take a look. So we're going to continue with solving problems using equations. So here's the problem. After looking at the pattern of big C's tiles at the right, James came up with the rule y equals 6x plus 3, where x represented the figure number and y represented the number of tiles in the figure. It's important to know what represents what, right? What x stands for and what y stands for. It says use the rule to find the number of tiles in figure 3. So it tells you the figure number. So when it tells you it's figure 3, are they telling you x or are they telling you y? What does it say in the problem? What does x represent?
The figure number.
The figure number, okay. So they're telling you here x equals 3. So we're going to solve for y. So we've got 6 times 3 plus 3. So the number of tiles is supposed to be 18 plus 3 is 21. So let's check that by actually counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Okay. So it is correct. Penelope wants to know how many tiles will be in figure 50. Okay. How can you determine this? Write down in words what you would need to do with your rule to answer her question. Then answer the question. So in words, we would need to substitute. $50 in the place of what? What are we going to put 50 in the place of? Are we going to put it for y or for x?
X.
Right. Of x, then solve for y. So let's see, that'll be y is equal to 6 times 50 plus 3. 6 times 50 is 300. So this is 303. Any questions about that? All right, so now Lou wants to reverse the process. He says he has a big C's figure made up of 45 tiles and wants to know the figure number in this pattern. In the rule, y equals 6x plus 3, which variable must equal 45 to solve Lou's problem? Which is it?
Y.
It's got to be the y. So let's write the equation. That'll be 45 is equal to, what was it? 6x plus 3. All right, so Isabella, what would you do next? Yeah. Make a zero pair by subtracting 3 from both sides. 42 is equal to 6x. Then what would you do, Kiara? Yeah, divide both sides by 6. It takes 6x to make 42. So the figure number is equal to 7. Now, Norm, on the other hand, says he has a big C pattern made up of 84 tiles. He wants to know which figure number the pattern is. So the 84 goes in the place of the y. That's going to be equal to 6x plus 3. The process is exactly the same as it was last time, right? We'll make a 0 pair by subtracting 3 from both sides. We get 81 is equal to 6x. We'll divide both sides by 6. See, 81 over 6, 6 won't divide evenly into 81, but I can reduce that, right? What will divide evenly into both of those? 3. Do you guys know the rule for figuring out if something's divisible by 3? Yes.
It's like one of the sum of all the digits is divisible by 3.
Yeah. So if I add these two together, 8 plus 1 is 9. Is 9 divisible by 3?
Yes.
Then so is 81. Okay? So 3 into 81, I happen to know that one, but just to show you. So that's going to be 27 over 2 is x. And if we make that a mixed number, that's 13 and a half. Does that solution make sense, though?
Yeah, no.
No. Why?
Because because 13.5, 84, you can't evenly make that pattern out of 84
Yeah.
squares.
There is no 13 and a half figure number, is there?
No.
The figure numbers all have to be whole numbers. Okay? Let's go on to the back. All right. So, Kira, if you ever see that in problems spelled this way, that's my daughter's name. Kira.
That's how you say Kairos? Or
Yeah, it's pronounced Kira. It's originally Russian, I think. It means princess.
like Sarah?
No, not quite. All right, so, and if you see James, that's my son. All right. So Kira was looking at the following table of data for how a tree increases in height as it gets older. Assuming that the tree continues to grow at a constant rate, they don't, but we'll assume that. Find a rule for the height of the tree using x and y. Identify what x stands for and what y stands for. Okay, so when you're deciding what to use for x and what to use for y, we typically use x for what's in the table and for in the original part of the table, and y for what we're getting out. So we're going to let x equal the number of years after planting. And let y be equal to the height of the tree in feet. Occasionally I have students who are like, they don't want to write all that down. You're just copying something. It's not super hard. You're just deciding which is which. But then you're just copying what's already in the chart. Now, finding the rule involves two different parts. So notice these are in 1 year increments, right? How much did the tree grow between year 3 and year 4? 4 feet. And from year 4 to year 5? 4 feet. So the rate of growth is 4 feet every year. But if you just multiply 3 by 4, what do you get? 12. Does that get me to 17? How much short am I of 17? 5. If I multiply 4 by 4, what do I get? How much short am I of 21? Oh, hey, this is coming up to be a pattern. If I multiply 5 by 4, 20, how much short am I of 25? 5. So I can write that this is equal to, either you can write 5 plus 4x, or y equals 4x plus 5. Either one of them is just fine. Notice in this part is the growth rate. How fast is it growing every year? It's growing 4 feet every year. What do you think that this number tells you? Pardon? So what do you mean by the starting? You're right. You're absolutely right. What do you mean by that?
It started at 5 feet.
Okay, so the tree was 5 feet tall when it was planted. Okay, you're exactly right. This is the height of the tree when planted. What year was that? If no, not that kind of year. Is that year 7, year 4, year year 0? Because when you planted it, how many years has it been since you planted it? None? Exactly.
It was 5 feet tall.
Pardon?
So it's 5 feet tall.
It was 5 feet tall when they planted it, and it's growing 4 feet every year. Now, is this actually how trees grow? Well, typically not. Okay? And it's not even as simple as they grow fast at first and then they grow slow later on. A lot of times they grow real slowly until they get out of what my dad used to call the grass stage. And then they grow quickly for a while and then it slows down again. Anyway, Kira wants to know how tall the tree will be 20 years after planting it. Let's use the rule. So the 20 years, where does that go? Does that replace the x or does it replace the y? The x, because x is the number of years after planting. So we'll have y is equal to 5 plus 4 times 20. That's 5 plus 80 is 85 feet. Be sure to put units in your answer.
Is that 8 stories or no?
85 feet? No. A story is typically in like a high-rise building is like 10 to 12 feet. So that's still pretty tall. All right, the tallest tree in the world in Montgomery Woods State Reserve in California is 367 feet tall.
That's tall.
That's very tall.
Very tall.
That's over a football field tall. Okay? Kira wants to know how long it would take for her tree to get that tall if it keeps growing at the same rate. Again, so 367, is that going to be the x or is it going to be the y? Please stop.
Oh, it's Y.
It's the y. So 367 is equal to 4x plus 5. So let's solve this. Jill, what would you do first? I definitely would not divide first. It's okay if you do, but it makes it a lot harder. You want to try again? If you don't, it's okay. Pardon? Yeah, subtract the 5. And when I'm asking somebody a question, don't be whispering or distracting them. And now let's divide by 4. That's 90.5. So 90 and a half years. So if she planted it when she was really young and it grew at 4 feet a year for her entire life, she might get to see that. Okay, any questions? All right.